Hello all. Let's get learn about the rate limiter. Okay. So rate limiter block the first derivative of the signal passing through it. The output changes no faster than the specified limits. The derivative is calculated using the equation. Here you can see we have one equation with rate. It divides that rate and we will get one slew rate from it. Okay, with this equation. Where UI and TI are the current block inputs and time. And U and Y minus Y I minus 1 and TI minus 1 are the output and time. Okay, at the previous step. Okay, the output is determined by comparing rate to the raising slew rate and falling slew rate parameters. Okay, so here you can see there are a few more equation for raising slew rate and falling slew rate. In using this, it will be calculated. Okay, and there are a few more that how we can calculate that also rate limit using sample time, and so many things will be here mentioned. Okay, so in a rate limiter example, you can see here I have that same sequence here, but my rate is limited to 0 to 1, 1 to 0, or in that way it is work. So you can see if we can come here at rate limiter, it limits the raising and falling rates of the signal. I have limited my raising and falling rate to 1 to minus 1. Falling rate will be minus 1 and raising rate will be 1. Okay, if I am going to change it to, you can see, suppose I am going to change to 5 and this side will become minus 5. Now you can see what is going to happen here in this graph. I have changed the rates. Okay, I have changed the rates. So you can see now it is taken, the much more inputs are covered in this. Okay, it is a rate limited. Okay, limited, that limits are increased in that way, you can say. Okay, so next block is saturation. Saturation is very important. Okay, the saturation block produce an output signal. Okay, saturation block produce an output signal that is the value of the input signal bonded to upper and lower saturation values. The upper and lower limits are specified by parameters, upper limit and lower. Okay, so here in a table you can see the input and what is the output desired for. If lower limit is greater than equal to input values and input values are greater than equal to upper limit, okay, if my upper limit is maximum, so the output will the output will be the input value. Input value is in between the range what we want, so output value will be the what is the input, that's the output. If my input value is less than lower limit, then what is my lower limit? That thing has work as a lower limit. Okay, so here you can see if my input values is greater than upper limit, then what is my input? Then it comes as a output here. Okay, upper limit will become output. You can see in this graph, and I'll create one more live example in front of you now. That also you can see. Here my upper limit and lower limit is bounded with these outputs. But that basic one example I want to take here with help of this saturation block and one display. I'll show you what is the output of this. Okay. Okay, I'll take one constant as an input. Okay. Now you can see if I'm opening this block, you can see limit inputs the signal and upper and lower saturation value. So here are the upper limit and lower limit. In this, my upper limit is minus 0.5 to minus 0.5. Okay. So here you can see if my input is 1, so my output will be 0.5. It will not become that 1. It will not become a 1. It is greater than that. What condition is passed here? You can see my upper limit input is greater than upper limit. So my upper limit will be the output. If I am changing this to minus 1, then minus 0.5 should be the output. You can see now. Okay, see in display minus 0.5 should be the output. So that second condition is also satisfied. If my input is like 0.2, okay, it's in the range between 0.5 to minus 0.5. Okay, so exactly what is the input, that should be my output. See, it's minus 1, 8.2. Okay, so that's all about the saturation block as well. Okay, now we will learn about this quantizer. Okay, so the quantizer block discretizes the input signals using a quantization algorithm. The block uses a round to next method to map signal values to quantized values at the output that are like all the that all are defined by the quantization interval. The smooth input signals can take one a step shape after the quantization. They like here you can see the equation mathematically how round to next method will be used. Y is equal to q into round u by q. So where y is quantization output, u is an input, and q is a quantization interval. So if I'm opening this, you can see this is a discretized input to be given. Here I have given quantization input interval is 5. Okay, and the sequence, repeating sequence, -4 to 5. Okay, if I'm simulating here, you can see my inputs are quantized. My inputs are quantized in this way. It's coming like it's going from -5. My inputs are starting from -4, but it is like whatever it is becoming, it's taken a one range, another interval. This is in the next interval, and it's divided in that interval. It's quantization, quantizer. Okay, so that's all about the discrete continuities library blocks. We have studied this 5. One is backlash, dead zone, rate limiter, saturation, and quantizer.